This training will cover the basic things needed to select and size valves. We'll start by looking at the basic valve functions, then the types of valves and important specifications like pressure and leakage ratings. Then I will discuss how valves are controlled and the difference between two-way and three-way valves. Next, we will cover each type of valve in some detail. Then I will describe how to properly size a control valve in an HVAC system, and we will finish with some common ways each of these valves are used. Valves control the flow of water and other media. Many valves are turned or actuated by hand, but by adding a motor, they can be controlled automatically. Heating and cooling systems use both manual and motor actuated valves, but we will focus on those that are motor actuated. Valves that simply turn flow of water on or off are called two-position valves. Modulating valves are used to deliver a certain amount of water to a heating or cooling system. Rather than simply turning the flow on or off, they can deliver partial flow to deliver just the right amount of heating or cooling. Diverting valves have one inlet and two outlets and direct the flow of water one way or the other. These may be used to send water or divert water around a device. Mixing valves have two inlets and one outlet. Often they will take hot or cold water in and deliver warm water out at a certain temperature. Valve action refers to what motion is required to open and close the valve. Rotary valves are turned to open and close. Linear valves are pushed up and down. It is important to know which type of valve action you have before you select the actuator, as this may affect the type of actuator you need. We will learn more about these types of valves later, but let's go over the basic types of valves to get started. The zone valve is a type of plug valve. It uses a rotary motion to pull a ball, called a plug, away from the inlet to open. Ball valves have a ball with a hole through them. It is also a rotary valve. As the ball turns, it allows or restricts flow. Butterfly valves have a disc that rotates, allowing water to flow. When closed, the disc fits snugly against a resilient liner that allows for a very tight shutoff. Globe valves have a shaft, called a stem, with a plug on the end. As the stem and plug move up and down through the valve, the flow is controlled. Cage valves have an insert that moves up and down inside a sleeve called a cage. The holes in the cage affect the flow characteristics. Most heating systems are closed loop. This means that the system is sealed off from the atmosphere. If a system is open to the atmosphere, it is called an open loop system. An important difference between open loop and closed loop is that the closed loop system is designed to be free of oxygen. Valves, circulators, and other components designed for a closed loop system must not be used in an open loop system as they may rust. Some cooling systems called cooling towers are open loop, so valves must be selected that can tolerate the oxygen in the water. Honeywell VFF butterfly valves can be used in open and closed loop systems and are often used with cooling towers. Of course, when water gets too cold, it freezes. Frozen pipes not only result in equipment failure, they can cause expensive property damage. For this reason, water used in heating and cooling systems may be mixed with glycol in order to reduce the freezing point. Up to 50% glycol is common. It is important to verify that the components you choose are compatible with glycol if it is used. Steam systems are generally categorized into low pressure and high pressure steam. Those operating above 15 psi are called high pressure. Steam is extremely hot, of course, and this could damage plastic valve components. Honeywell globe valves such as the VGF and V5011 are rated for steam, and there are models for low and high pressure steam. The static pressure rating of a valve is simply the maximum static pressure the valve is designed to handle. Obviously, the rating of the valve must be greater than the designed maximum static pressure of the system. Static pressure is created by the fill pressure of the system, the circulating pump, called pump head, and by the gravity from the weight of the column of water. Commercial control valves for water often have static pressure readings in the 150 to 360 psi range. The job documentation should state what static pressure ratings are required for each valve. Although proper selection is important for safe and reliable operation of the system, it does not impact the controllability of the system. When a valve is closed, there is higher pressure on the pump side than on the other side of the valve. This pressure is caused by the circulating pump and is measured between the inlet and outlet of the valve. Close-off pressure is a maximum pressure differential that a valve can withstand in a closed position without exceeding its leakage rating. The close-off rating must be equal to or greater than the required close-off pressure. The job documentation should contain this information. If a valve actuator assembly cannot completely close off against the pressure in the pipe, the water or media will leak through, causing noise, premature valve wear, and system inefficiencies. Different valve styles have different close-off pressure ratings because of how they're designed. With plug valves and globe valves, the close-off ratings depend on actuator power because the plug is pushing against the water pressure. The stronger the actuator, the higher the close-off rating. The actuator of ball and cage valves only have to overcome the friction of rotating the ball or opening and closing the cage, so these valves have the same close-off rating regardless of what actuator is used. Butterfly valves are similar to ball and cage valves with respect to close-off, but the amount of friction needed to be overcome is much greater because the disc must push into the resilient liner. A valve may leak externally or internally. Neither is desirable, of course. External leaks may be through the stem, the joints, or pipe connection, and are usually detected by dripping water. Internal leakage is flow through the valve in the closed position. The American National Standards Institute specifies 6 different leakage classes. Leakage is measured as a percentage of the CV. Some applications are more critical than others, and the job documentation will specify this. Flow characteristics refers to how the flow changes as the valve opens and closes. A quick opening valve provides large changes in flow for very small changes in valve opening. This is often used for 2-position valves that need to be either on or off. Zone plug valves and some cage valves are quick opening. They also have the advantage of a soft close, which minimizes water hammer. In linear opening valves, the flow through the valve varies linearly with valve stem position. Such valves are useful for controlling steam or for blending 2 streams together. Some globe valves are linear opening valves. An equal percentage valve increases the flow exponentially with valve travel. With this valve, equal increments in valve travel produce equal percentage changes in flow. Some globe and ball valves are equal percentage opening valves. It is best to control room temperature in a linear fashion, so that if the thermostat wants it to be 20% warmer, the coil will deliver 20% more heat. Heating coils have a characteristic similar to this one. Notice that the changes to fluid flow do not have a linear relationship to heat output. A thermostat would have a difficult time accurately controlling this. By using a valve with an equal percentage flow characteristic that counteracts the coil's characteristic, the heat output will be more linear. This makes temperature control much easier because now the heat output is linear with valve movement. Two-position valves usually control in either full open and full close positions. They may be used with motorized actuators for isolation on large cooling towers or boilers, or on smaller hydronic systems for heating. Two-position valves with manual actuators are commonly used to isolate a device for service. Modulating is a term used to describe a type of control that can position the valve anywhere between open and closed. Proportional is a type of modulation, where positioning is determined by an electrical signal. This signal directs the actuator to position the valve at a certain amount open or closed. The signal is a certain voltage or amperage that the actuator uses to go to the desired position. Floating control is a type of modulation based on timing. An electric motor is driven clockwise or counterclockwise for a specific amount of time to reach the desired position. Some valves have one inlet and one outlet. They are very common. Two-way valves may be controlled with either two-position, open-closed actuators or modulating actuators. Two-way valves with two-position actuators are used to allow flow or to restrict it for isolation or for some heating applications. Two-way valves with modulating actuators are commonly used in HVAC to control how much hot or chilled water to deliver for accurate temperature control. Three-way valves are characterized by having three connection points. Mixing valves have two inlets and one mixed outlet. These are often used to mix hot and cold water to deliver water out at a desired temperature. Diverting valves have one inlet and two outlets. These are used to direct the flow one way or the other. For instance, they may be used to deliver the flow of water to a device or to bypass around it. Plug-style valves are rotary valves that have a ball that closes off against a port to close off the flow. They are two-position valves that are often powered open and spring-closed. They are most often used to control closed-loop hot water, but may also be two-way and three-way. The globe valve is a traditional control valve. It has been used for many years and continues to be very popular. The body of a globe valve has a stem protruding through the top of it. Lateral up and down motion of the stem moves a plug into and out of an opening inside the valve. This method allows for fine control for accurate heating and cooling in closed-loop systems. Often the actuator mounted on the globe valve is a linear actuator that moves the stem up and down. Alternately, a rotary motion actuator may be mounted onto a linkage that translates the rotary motion into a linear motion. Globe valves are often used to control hot water, chilled water, and steam. Inside the body of a ball valve is a ball with a hole through the center of it. A stem at the top of the ball protrudes through the top of the valve and allows the ball to be turned either manually or with an actuator. You may have noticed these valves in your house. The gas line and water line are often used with manual ball valves like this one. Traditional ball valves were two-position, either open or closed. But many modern ball valves are able to operate as proportional valves. An insert in the ball makes the flow control very similar to a globe valve. These are also called characterized ball valves. These valves may be two-way or three-way and are used with hot and chilled water in closed-loop systems. A cartridge globe valve is a type of globe valve, so it is very good at controlling the flow in modulating applications. What makes it different is the way it is serviced. The cartridge replaces a number of individual components on the stem into a one-piece device that can easily be replaced when the valve is serviced. This is easier and saves time. Cartridge globe valves like the Honeywell V58 have actuators that easily thread onto the valve body to make installation and service quick and easy. Cage valves have an insert called a plug that moves up and down inside a sleeve called a cage. As the plug moves, the water is allowed to flow in and out of holes in the cage. The holes can be shaped to control or characterize how the water flows. Because the valve is not pushing a plug against the flow, the close-off pressure is not dependent on valve size. Honeywell VC valves all have close-off pressure of 60 psi and have actuators that mount easily onto them. VC valves are also easy to service because the cage is a cartridge that can be easily replaced. Cage valves may be used in two-position and modulating control and are not sensitive to the flow direction. A butterfly valve is similar to a short segment of pipe with a disc inside of it. The disc is mounted on a stem that protrudes through the top. Rotating the stem rotates the disc to control the flow. Butterfly valves may be two-way or be manufactured as three-way valves. They are used for two-position or modulating control of hot water and chilled water in closed and open loop systems. They're usually used on larger applications. Honeywell VFF valves are available in sizes up to 20 inches and have very low leakage. Next, we will look at how to properly size a valve. It is important to know that pipe size only refers to the size of pipe that the valve is designed to work with. Valves of the same size may be manufactured to produce more or less resistance to flow. This resistance is called CV. Two-position valves are usually selected with a low resistance to flow. So the valve is usually the same size diameter as the pipe and has little pressure drop. Modulating control valves need to have some resistance to the flow for accurate control and may be sized smaller than pipe size. CV stands for valve coefficient and is needed to select the proper valve. In order to size a valve, we need to know the GPM and the pressure drop. GPM is the flow of water in gallons per minute. Pressure drop is caused by resistance to flow and is measured in pounds per square inch, or PSI, and is often referred to as delta P. CV is a measure of the resistance to flow created by the valve. CV is the flow of water in gallons per minute with a pressure drop across the valve of 1 pound per square inch. As you can see in the chart, a valve of a certain size, say a ½ inch, is available in more than one CV. The valves with the higher CV have less resistance to pressure, or pressure drop, than the ones with a lower CV. This is critical in selecting the right valve. Often with a two-position on-off valve, it is desirable to have as much flow as possible. In this case, the valve with the highest CV should be selected. Additionally, as CV is the GPM going through a valve at 1 psi drop, you may select a valve with a CV equal to or greater than the GPM required. In plug zone valves and globe valves, the close-off pressure is higher in zone valves with lower CV. So where high close-off pressure is needed, a lower CV value may be needed. With valves used for modulating proportional control, it is critical to select the correct CV in order to have good temperature control. If the valve CV is too large, it will operate at a very small opening, resulting in very poor control and possible valve or actuator damage. If the valve CV is too small, it may not provide enough flow to the application, resulting in insufficient heating or cooling. Properly sized control valves will control flow over the entire range, from open to closed, providing optimal temperature control. To properly size control valves, select the control valve to yield a pressure drop equal to the coil. So, if you have a coil with a 4.2 pressure drop, then divide 60 by the square root of 4.2. Usually, the GPM is known, but the coil pressure drop may not be. In this case, size the control valve to have a pressure drop of 3 to 5 psi. Often 4 psi is used, as this makes the mathematics very easy, as the square root of 4 is 2. So the CV is found by dividing the GPM by 2. Now we'll look at how these valves are used. Mechanical rooms have boilers, chillers, heat exchangers, thermal storage units, and more. They need isolation valves, control valves, and bypass valves. Commonly used valves for these applications are ball valves, butterfly valves, and sometimes globe valves. Cooling towers extract heat from the chilled water to cool and dehumidify the building. They are open loop systems requiring butterfly valves suitable for open loop systems. An air handling unit is a central air distribution unit providing conditioned air to a building. Air handlers heat and cool the air in various ways. Some use hot and chilled water through coils to condition the air. Other means of heating and cooling are electric, gas, or DX coils. Most water coil air handlers use globe or ball valves for control. Very large units sometimes use butterfly valves. A terminal unit controls temperature in a segment of a building called zones. They provide conditioned air from the air handler. Some are air cooling only and simply regulate airflow volume with a damper. Others have a reheat coil to provide heating capability. Terminal units' control valves are floating or modulating and are usually ball valves or cartridge globe valves. Next, I will talk about radiant heating. A common type is baseboard heating that has been used in homes for many years. In commercial applications, it is often referred to as perimeter heating. It is hot water that flows through a pipe with fins that warms the air with radiant and convective heat. Radiant floor is similar, but the pipes run under the floor, and the heat radiates up from the floor to the entire area. Snow melt is similar, but outdoors. It warms sidewalks and driveways to be clear of snow. Obviously, this water must not freeze, so it is mixed with glycol to lower the freezing point. In certain locations, radiant cooling may also be used, but it is critical that the surface, the floor perhaps, does not cool below the dew point and become wet and slippery. These applications may use ball valves, cartridge cage valves, and globe valves, or plug-style valves. The valves may have two-position actuators with or without spring return, although modulating actuators are also used. The chilled beam is a method of cooling a zone with chilled water rather than forced air. Although there are several different styles, they all cool with coils of chilled water. In some systems, the air around the coil is cooled and convection cools the area. In other types, the area is cooled through radiant cooling. Some systems will use a combination of convection and radiant cooling. Of course, moisture will condense in the air if it is too cold, so methods of managing this condensate may be used. And this type of system tends to be used in drier climates. Ball valves are often used with chilled beams, and the actuator is usually a modulating one. Unitary refers to self-contained heating devices. A common type is a heater high on the wall like this one. Some heat with gas, but others like this one use a hot water coil and a fan to heat the area. The valve is often a ball valve and may either be two positioning or modulating. Unit ventilators and fan coils are used to condition a single room. Unit ventilators consist of dampers, a filter, a fan, and heating or cooling coils and controls. They heat or cool outdoor air, return air, or a mixture to condition the space. The heating may be done with hot water and a coil, steam, or electric resistance elements. The cooling may be chilled water and a coil, or mechanical refrigeration with a DX coil. They are used for a single zone control where controlled ventilation is necessary, such as classrooms and conference rooms. Unit ventilators are very similar to the next unit called a fan coil. Fan coils are similar to unit ventilators, but do not have an outdoor air intake. They are often used in apartments, offices, hotels, and hospital rooms. The flow of hot water or chilled water through the coil is often controlled with a cage valve or a ball valve. A diverting valve may also be used to deliver either hot or cold water to the coil for heating and cooling. They are usually controlled with a modulating actuator. This concludes Honeywell's Commercial Control Valve Fundamentals. For more information on valves, visit us at buildingcontrols.honeywell.com.